This is Dr. Masood Yusuf from the Division of Science and Technology, University of Education, Lahore. I am going to be your instructor for the course Introduction to Material Sciences. This video lecture is all about composites. As you can see from the table of contents, we will cover all key aspects relating to composites in a short period of time. We will begin from defining composites, their types, and how they are made. After discussing types of composites, we will cover factors affecting properties of composites. Lastly, study material will be shared. Let us start the lecture by discussing what is a composite. Composite materials are formed by combining two or more materials that usually have several different properties. So, a composite may be consist of two different types of materials having different physical properties such as structural properties. A composite is not restricted to only two materials. A composite may consist of more than two materials. Let us discuss this schematic diagram of a composite. So, in a composite, we have two types of materials. Material A, shown by these rod or fiber-like structures. Material A is in the form of fiber, also known as reinforcement, and is easily distinguishable in the composite. Material B is in the form of matrix and is also easily distinguishable in a composite. In a composite, material A and B do not dissolve or blend into each other, and each participating material is easily distinguishable. So, this is our definition of a composite. In short, we can say that a composite may consist of two or more than two different types of materials that do not blend or dissolve into each other. What are the types of composites? There are two main types of a composite. One known as natural composites and the other one is synthetic composites. As the name suggests, natural composites exist in both animals and plants, whereas synthetic composites are man-made composites. Let us give some examples relating to natural and synthetic composites. In natural composite, one everyday example of a composite is wood. Wood is a combination of cellulose fibers, which are a kind of polymer, and lignin, which is a much weaker substance as compared to cellulose and is shown by pink strips in this diagram. By combining cellulose fibers and lignin, we have a composite known as wood. Wood is much stronger than individually lignin and cellulose. Cellulose is also found in cotton, but without the lignin to bind it together, it is much weaker. So, the individual materials, either cellulose or lignin, they are not that much strong. But by combining these two materials, we get a much stronger material known as wood. In animals or in human beings, bone is a composite natural material. It consists of hydroxyapatite, which is mainly calcium phosphate, and is hard but brittle material. Brittle means they can easily break and they do not have flexibility. Another material which participates in making bone is collagen, which is a protein and is a soft and flexible material. By the combination of hydroxyapatite and collagen, bones are formed which are not only strong but also have some degree of flexibility. Let us also give some examples relating to synthetic composites. Some example from early composites made by human beings. Mixing mud and straw together to make bricks that are resistant to both squeezing and tearing and make excellent building blocks. Bricks alone are strong. If you try to squash it, it has a good compressive strength, but it breaks quite easily if you try to bend it. It has poor tensile strength. In more recent times, it has been found that adding metal rods or wires to the concrete can increase its tensile bending strength. Concrete containing such rods or wires is called reinforced concrete. Mixing mud and straw together and reinforced concrete are some examples of synthetic composites. Some examples from the modern synthetic composites. Fiberglass is still widely used today for boat hulls, sports equipment, building panels, and many car bodies. Fiberglass is an example from modern composites. The matrix is a plastic and the reinforcement is glass. That's why the name appears as fiberglass. It has been made into the fine threads and often woven into a sort of cloth. Glass alone is very strong, but brittle, and it will break if bent sharply. The plastic matrix holds the glass fibers together and also protects them from damage by sharing out the forces acting on them. Thus, by building objects such as car bodies or boats from fiberglass, make them much tougher and strong. Some advanced composites are now made using carbon fibers instead of glass. These materials are lighter and stronger than fiberglass, but more expensive to produce. They are used in aircraft structures and expensive sports equipment such as golf clubs, offer possibilities for making lighter cars and aircraft. Carbon fibers are one of the exceptional example of modern day composites. What is the importance of composite? Why we should bother about composites? Mainly because they have high strength, they are also lightweight. So these two features are very important. Ratios of strength to weight and stiffness to weight are several times greater than ordinary materials. They can be used to strengthen of parts, their net shape for manufacturing is very flexible, and they can be molded into variety of shapes. Fatigue properties are generally better than for common engineering. Composites have a very good fatigue properties, and they can withstand cyclic stresses very well. Toughness is often greater too. Composites can be designed that do not corrode like steel. Possible to achieve combinations of properties not attainable with metals. So we have discussed several great properties of composites. Let us now discuss components of composite materials. What are the main components that are involved in making a composite material? The main components are matrix and reinforcement. Reinforcement is also sometimes called fibers. So, if we have a look onto this schematic diagram of a composite, we can see that a composite consists of two types of materials. One is fiber or reinforcement, as shown in the figure, with the help of rod-like or fiber-like structures, and they are easily distinguishable even though the composite is formed. The second material that participate in making composite is material B, which is matrix, and it is also easily distinguishable in the composite. In a composite, material A, which is reinforcement or fiber, and material B, which is matrix, do not dissolve or blend into each other. Reinforcing materials are strong with low densities, while the matrix is usually a ductile or tough material. Composite combines the strength of the reinforcement with the toughness of the matrix. This is not available in any single conventional material. So, in a composite benefits from the properties of both the participating materials. What is the role of matrix? It mainly holds the fibers together. It protects the fibers from environment, from the external effects of the environment. It distributes the load evenly between fibers so that all fibers are subjected to the same amount of strain. It improves impact and fracture resistance of a component. And what is the role of reinforcement? It has very good tensile properties. It has improved stiffness, and it has a quality of impact resistance, and it can resist the impacting forces. What are the main types of composites? Mainly composites can be classified into fiber composites, particle composites, flake composites, laminar composites, and lastly field composites. Let us discuss each of these types briefly. Fiber composites. In fiber composites, the fibers reinforce along the line of their length. Reinforcement may be 1D, 2D, or 3 dimension. So, for example, in this left hand side figure, 1D reinforcement gives maximum strength in one direction, that may be X, Y, or Z direction. This middle schematic diagram informs us that 2D, two-dimensional gives strength in two directions. So, fibers in this case strengthen the composite along XY plane, for example. And lastly, this right hand side panel, it shows isotropic gives strength equally in all directions. Isotropic means that the strength does not depend on direction and the fiber reinforce along all the directions equally. 1D and 2D are anisotropic while 3D is isotropic. Particle composites. Particles usually reinforce a composite equally in all directions, called isotropic, because they strengthen the material in all directions, so they do not depend on direction. That's why we have used the term isotropic. Let us discuss the example of particle composite. Ceramides. A ceramide is a composite material composed of ceramic and metal. The ceramide word is composed of some part of the taken from ceramic and metal. For example, oxide based ceramides, which are for example combination of aluminium oxide with chromium. Carbide based ceramides, it has tungsten carbide or titanium carbide ceramides. So in ceramides, the for example in this oxide based ceramide, chromium is the particle that equally spreads in all directions and reinforce the composite. Flake composites. Flakes, because of their shape. What is flake? A small, flat, very thin piece of something is called flake. This is just the definition from a dictionary. Flakes, because of their shape, usually reinforce in 2D, as flake is something very thin and flat extending along a plane. Two common flake materials are glass and mica. Mica is a shiny silicate mineral with a layered structure. Laminar composites. A laminar composite is shown below. Platelets or lamina consist of panels or sheets which are two-dimensional, as you can see in this figure. They are called platelets or lamina. These panels possess preferred directions to achieve high strength. Plywood is an example of laminar composites, which is a laminated composite of thin layers of wood in which successive layers have different grain or fiber orientations. The result is a more or less isotropic composite sheet. So each platelet is strengthened along a specific direction, but combining several platelets or lamina, we have a composite known as plywood, which is a more or less isotropic composite sheet. Filled composites. Filled composites consist of a skeletal 3D matrix holding a second material. As you can see in this right hand side figure, we have a 3D skeletal and it is holding a another material. The most widely used composites of this kind are sandwich structures and honeycomb structures. So this is one of the sandwich structure shown on the right hand side. Let us discuss what are the factors that affect the properties of composites. The type, distribution, size, shape, orientation and arrangement of the reinforcement will affect the properties of the composite materials and its anisotropy. Here is the list of study material that include books and educational web links. Students can go through these materials in order to develop sound understanding on aforementioned topics. Thank you for having me. That's all.